Been looking for this bird all day.
Yo, what are you doing?
Man, Mr. Nickerson wants us to teach the whole class Heron's formula,
Dude,
and I'm just looking for the bird that made it.
It's pronounced Hero's formula, and lucky for you, the person that invented it, Hero of Alexandria, is right in this building. Let's go.
Really? Hero of Alexandria? What are you doing here? I thought you died in 70 AD.
Oh, well, I came back to give you this formula sheet. Mr. Nickerson said you're going to need it for class.
Thanks, man.
You got
Have
it,
a
Nick.
great day.
Good luck.
Chapter 4.6, Hero's formula, is used to find the area of a triangle when all three side lengths are known, and it's used to find the length of an altitude when all three side lengths are shown. So step one, you're going to find the semi-perimeter of your triangle, and that's by adding up all three sides and then dividing by 2. And once you get your semi-perimeter, which will end up being x over 2, you're going to simplify that into a whole number, and then you simply just plug it in to this area equation. So, all right, so we've got our triangle, and then first thing we're going to do is want to find the semi-perimeter. So we're going to come over here, and we're going to set up our formula. So semi-perimeter, a plus b plus c over 2, and you end up with s over 123. S equals 123 over 2, which ends up being 61.5. So now that we know that s is 61.5, we can just plug it into our formula. K equals root 61.5 times 61.5 minus 44 times 61.5 minus 29 times 61.5 minus 50. And you can just put it simply into your calculator as such. Second, x squared, that becomes the square root. Then 61.5 minus 44, 61.5 minus 29, 61.5 minus 50. And then once you get those all in, you hit equals, and this is your answer. And then you simply just round to the nearest tenth.
All right, so for the next problem, essentially what we're going to be doing is finding the altitude. So we're going to be finding the altitude from angle C to side AB. And it does have to have a 90-degree angle when you put it down. So if it goes outside the triangle and looks like this, it's completely fine. So the first step to doing this is very similar to how we did it the last time, solving for the area. So you're going to take your sides, 3, 4, and 2, and you're going to add them up, divide them by 2, and you're going to get a final answer of 4.5. You're going to take that 4.5 and plug it into this equation right here, as seen before. You're going to get this answer right here, which then you're just going to round to the nearest tenth, which is going to equal 2.9 units squared. Now, the altitude part comes in right here. You're going to be plugging the 2.9 units squared into the 1/2 base times height thing. So you're going to do 2.9 equals 1/2 times 2, which is the base, times h, which is the height, which is what we're going to be actually solving for. So 2.9 equals 1/2 of 2, which is 1, times the height. You divide by 1, and then you get the height equals 2.9 units. Hey, what's up, O'Connor? All right, so for our final type of problem, we're going to be finding the area of a quadrilateral. So the key to this is actually taking the quadrilateral and splitting it into 2 triangles through the auxiliary line, which is the center line that you're going to be needing to find. So to find the auxiliary line, you need to have a lot of cosines down and understand that. So if you don't understand that, which I'm sure you guys do, it's right here. So x squared equals 12.4 squared plus 14.1 squared minus 2 times 12.4 times 14.1 times cos of 88. And then right here you get 340.36666344. And then what you do is you're supposed to actually, square root that. And then you're going to get 18.44902014, and then just round to the nearest tenth. So you're going to get 18.4 for your auxiliary lines. So we're just going to write that down, and we're going to move to the next step.
So now we're going to solve for the area of one of the triangles, and in doing so we're going to use the side angle side method, which if you have an angle and two of the sides are named on either side of it, on both sides of it, then you can do this method, and it's very quick. It's 1/2 base times height, and then times the sine of whatever your angle is. So for this one, it would be 1/2 times 12.4 times 14.1 times sine 88, and enter that into your calculator as is. You'll get 87.5 3667461 units squared, and then you simply just simplify that to the nearest tenth, and that's your first area.
All right, so for the final step, you're going to be doing what you have been doing. You're going to be finding the area of this triangle right here. So we're going to add up A, B, and C, which is going to equal 42.6 over 2, which is going to simplify to 21.3. You're going to plug 21.3 into your standard Heron's formula equation, and you're going to get this big number, which rounds to 59.6 units squared. So pretty much the final step is just adding this angle area and this triangle area and adding this triangle area up together. So we're going to add this one right here, which is 87.4, and you're going to be adding this one here, which is 59.6, and that's going to equal 147 units, and you're just going to make sure to square that as well.
So we're going to be finding the area of a triangle with sides 16 meters, 14 meters, and 9 meters. So again, we're going to find our semi-perimeter, add up all our sides and divide it by 2, and we'll end up getting 19.5. Plug that into our area formula and do it out on the calculator just as it is right there. You should get an answer of 62.7808689, and simply just round to the nearest tenth to find your area, which is 62.8 meters squared.
All right, so we've seen this before. This is finding the altitude. So we're going to be finding it from angle C to side AB. So as you can see, there's A, B, and C right here. It goes to there. So you're going to find your semi-perimeter first, add 16, 22, and 18 up, divided by 2, and you're going to end up with a final answer of 28. You're going to plug the 28 into the form to find the area. And once you put that all in your calculator, you're going to get an answer of 141.9859148. But really, you're just going to round to the nearest tenth, which is actually going to round to a whole number of 142. And so there's two main steps, obviously. So step 2, you're going to plug it into the 1/2 base times height. So you're going to have 142 equals 1/2 times 22, which is the base, times h, which is the height. 1/2 of 22 is 11, so you're going to get 11h. Divide by 11 to isolate the h on each side, and then you're going to get 12.9 units for the height.
All right, so for this problem, we're going to find the area of the quadrilateral, and what we need to do is draw ourselves an auxiliary line, which is x, so we can split the quadrilateral into 2 triangles, because to find the area of a quadrilateral, you need to find the area of the 2 triangles and add them all together. So to find the auxiliary line, we're going to do the law of cosines formula, which is x squared equals 87 squared plus 125 squared minus 2 times 87 times 125 cosine of 72, and you're going to get 128.3 is your auxiliary line. And then after that, you're going to want to find the 2 triangles area. So obviously for this one, remember, we have side angle side. So if we have an angle in between the 2 sides given, we can just plug it into this formula. 1/2 base times height and then sine. So it would be 1/2 87 times 125 sine of 72, and you're going to end up with 5,171.4 units squared as your first area. And then after that, you're just going to solve normally for this one like all the other ones. You're going to get your semi-perimeter, which after you do it all together equals 151.65. Simply plug it in the equation like before, and you'll get 3,502.8 units squared. And after that, all you got to do is add the 2 areas, and you'll get your final answer of 8,674.2 units squared.